So in these problems, we're talking about chords. With the chords, the main thing we're going to be doing is the Pythagorean theorem. What we want to know is that if a chord is crossed by a diameter, it's going to be bisected. So that means that if this segment is 12.2, this other segment is also 12.2. And notice my right angle right here. That gives me a right triangle that I can use to find x. There's my lovely right triangle. So I can have my first leg squared plus my second leg squared equals my hypotenuse squared. 5.4 squared plus 12 squared gives me 178. And then I need to take the square root of both sides, and that gives me 13.3. And we're basically going to repeat this process for the next two problems. In problem 2, if this part of the chord is 16.3, the other part is also 16.3. So I can say 5.6 squared plus 16.3 squared equals x squared. So that's 31.36 plus 265.69 equals x squared. So x squared equals 297.05. Take the square root of both sides, and I get that x equals 17.2. Last but not least, this one is a little bit different because I'm going to be solving for one of the legs. So my equation would look like 14.5 squared plus x squared equals 18 squared. So that would be 210.25 plus x squared equals 324. Subtract from both sides. And take the square root, which gives me 10.7. The final problem in this section asks us to notice that if two chords are perpendicular and congruent to the same segment, then the chords themselves are congruent. So 3x minus 11 equals x plus 9. Combine your like terms, so subtract x from both sides. Add 11 to both sides. Divide by 2. And that gives me x equals 10. If I look at my question, though, it says, what is CD? So I need to find CD. There it is. And now I need to substitute 10 in for x. So that would give me 10 plus 9, which is 19. So CD is congruent to 19.